Hello viewers, in today's class we are going to discuss yet another very important and conceptual problem from definite integrals, and here we are going to solve this important integral which is from 0 to pi by 2, and the integrand is theta times square root of 1 minus cos 2 theta, right? So here we have to evaluate this definite integral, and we'll see how the concept of absolute value function and the method of integration by parts shall be used to evaluate this integral, right? So let us start. So let us first call this integral as I, right? Now, before proceeding further, let us first use an important trigonometrical identity, right? Now see, here in the integrand cosine 2 theta appears, right? And we know that cos of 2 theta is given by 1 minus 2 sine square theta, right? So this is an important identity, right? Okay, so here cos 2 theta is equal to 1 minus 2 sine square theta. So we can now write 2 sine square theta is equal to 1 minus cos of 2 theta, right? So here we have square root of 1 minus cos 2 theta. So we can now substitute 2 sine square theta, right? So now our integral becomes 0 to pi by 2, and here we have theta, and here we have square root of 2 sine square theta and d theta, right? And now see, here we have two terms inside the square root symbol, that is 2 and sine square theta. So let us take square root of 2 outside the integral sign. So we have square root of 2, 0 to pi by 2 theta, and here we have square root of sine square theta d theta, right? Now see, here we have square root of sine square theta, right? So we cannot write sine square theta, the square root of sine square theta, as simply sine theta. Why? Because see, here the limits of integration varies from 0 to pi by 2, right? So if we see the sign convention in trigonometric functions, then we have here the four quadrants, right? So this is the first one, this is second, this is third, and this is fourth, right? Now see, the limits of integration varies from 0 to pi by 2, right? So we have to confine ourselves in the first quadrant, right? And in the first quadrant, we know that all the trigonometric functions are positive, right? So now let us see how we can write square root of sine square theta. So square root of sine square theta should be written as mod of sine theta, right? Because we know from the definition of mod function that square root of, say, y square is always equal to mod of y, right? And we define the mod function as mod of y is positive y whenever y is greater than 0, mod of y is equal to 0 whenever y is equal to 0, and mod of y is minus y whenever y is less than 0, right? So mod of y is defined as a square root of y square, right? And here we have square root of sine square theta. So square root of sine square theta should be written as mod of sine theta, and mod of sine theta is positive sine theta when theta belongs to 0 to pi by 2, right? Because 0 to pi by 2 represents the first quadrant, and in the first quadrant the sine theta function is positive, right? So now we can write this integral as a square root of 2, and here we have 0 to pi by 2, and we have theta, and square root of sine square theta is equal to positive sine theta, which we can simply write sine theta, right? Suppose if we had square root of cos square theta, right? In that case also square root of cos square theta should be equal to mod of cos theta, that is equal to positive cos theta, because we are in the first quadrant, and in the first quadrant all the trigonometric functions are positive, right? Okay, so now here we have an integral in which the integrand is the product of two functions, right? So here we have theta and here we have sine theta. So to integrate this function, let us use the method of integration by parts, right? So let us first write the formula for integration by parts, right? Suppose we have two functions u and v, which are functions of x, right? And if we treat this function u as first function and v as second function, then the integration by parts formula, it goes like this. We write u integral of v dx minus, then we have integral, and then we have derivative of u, and then we have integral of v with respect to x, right? And then this whole quantity should be integrated with respect to x, right? So here what we will do, theta is a polynomial function, right? And sine theta is a trigonometric function. So our choice is we'll take theta as the first function u, and sine theta as the second function v, right? So let us first calculate the indefinite integral of theta sine theta d theta, right? So by using this result, what we can write, see here, first we'll have theta, then integral of sine theta d theta minus integral, and then we have the derivative of theta with respect to theta, because here the variable is theta, right? And then we'll write the integral of sine theta d theta, and the whole quantity is again integrated with respect to theta, right? So now the well-known result for integral of sine theta is minus cos theta, and here we have integral, derivative of theta with respect to theta is 1, integral of sine theta is minus cos theta, and here we have d theta, right? So now this is minus theta cos theta, then minus minus plus, and here we have integral of cos theta d theta. So this is minus theta cos theta, and here we have integral of cos theta is sine theta, right? So now this integral can be written as square root of 2, and now we have to simply take the limits, and we can now write theta cos theta plus sine theta, and the limits of integration are from 0 to pi by 2, right? Okay, so now we have square root of 2. Now first we'll take the upper limit and we'll substitute it here. Then we have minus pi by 2 cos of pi by 2 plus sine pi by 2, and then we have minus sign here, and when we take 0 here, then obviously this quantity is 0, and then we have sine of 0, which is 0, right? And now we can write square root of 2, and here we have minus pi by 2, and cos pi by 2 is 0, and sine pi by 2 is 1, and here we have the entire quantity as 0, right? So now this expression is equal to square root of 2, and here this quantity is 0, so we are left with simply 0 plus 1, that is 1, 1 minus 0 is 1, right? So we have square root of 1 times 1, and that is equal to square root of 2, right? So viewers, the value of this integral is equal to square root of 2, right? And this is how we can solve these type of definite integrals.